So in this video, we're going to be exploring box and whisker plots and how to construct them. We need 5 things to be able to construct a box and whisker plot, and I'm going to be showing you guys how to do that with different data sets shortly. But first, let's review real quick what you guys are going to be learning in this unit. First, up here in yellow, you're going to understand the center and shape of our data can be used to describe differences between 2 samples or population sets. So basically, we're going to be making box and whisker plots and seeing the size of the box and whisker plot and drawing comparisons when we're comparing different data sets. In green here, you can see that we are going to also understand how to use the measure of center, which is the mean, median, mode, and range that you've already learned about in elementary school. And we're also going to explore measures of variability from different data distributions, and we're going to be, again, drawing different inferences about multiple populations. So first, what we have here is a scenario where the owner of a restaurant wants to find out more about where her patrons are coming from. So she gathers data about the distance in miles that people are commuting to get to her restaurant. And people have started to report the following distances traveled. So here we can see a list of the number of miles that people are traveling to go to this particular restaurant. And we see a couple ones in there. 1, 1, so a couple ones, which means that people live relatively close. There's also a few 2s and a few 3s. So we can see that we've got people who live nearby the restaurant going, and then we also can see like 30 miles, somebody traveled there to get to the restaurant. Now, of course, that person could be shopping and the restaurant happens to be near the store that they went to. But first, what I want you to consider is why might the owner want to consider this information? So just pause the video and give that some thought and jot down an explanation there as to why you think the owner of a restaurant might want to consider the distances that people are traveling to get to that restaurant. All right, so just pause and answer here, and we'll be talking about this in class. When you replay the video, it's going to pick up down below organizing the data. So what I've done here is I've taken the people who've responded and I've already organized them for you guys. That's going to be pretty tedious when you're left to do that by yourself. One strategy I recommend is to first up here count how many people there are, and then in the end, obviously, you can recount. Now this is going to be easier for you guys right here because I made a chart and I listed out that you should have 20 pieces of data, and so you know as you're filling it out, if you haven't filled them all out, then you must be missing a number. Another strategy that I have while you're doing this is to cross them out along the way. So as you look up here and you see that you've got a 1 and then another 1, when you write them here, just cross them out. Then as you see a 2, and a 2, just cross them out up here as you're listing them out, and then you'll know you've got all of the data in your list from least to greatest. Now, I do want to highlight here that we want our data to be organized from least to greatest because that's how we're going to identify the 5 parts that we need to be able to graph a box and whisker plot. Now, first, what we're going to do is I'm actually going to just show you guys with a bunch of different data sets how to find these 5 different parts needed for a box and whisker plot, and then we're going to go back to the example and actually identify the 5 parts that we need. So first, we're going to play around with the data set. If I have the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, and I've already got it listed here, what the different names are going to be, let me first show you how I find them. Now, the easy thing to identify first is going to be the lower extreme and the upper extreme. It's simply going to be the smallest number in your data set and the biggest number in your data set. And you'll use that to find the range. You might remember from elementary school that you take the biggest number minus the smallest number, and that's when you have the range. So here we have that the range would be 8, all right? The range here would be 8. Now that being said, let me walk you guys through how I found the median. So with the median, I'm basically going from this side to this side and crossing them out. Then I cross out another pair. The goal is to find the number in the middle, all right? So as we do that, we can see that 5 is going to be all by itself right there in the middle. And then I'm going to show you guys now, once you found a number in the middle, you basically ignore it for the next part, okay? Now to find the lower quartile, you're just going to reset, and you want to find the median of just this lower half of the data. So we're going to slash out the 1, then we slash out the 4, and then we have 2 numbers left over. So the lower quartile is going to be in between them, and you just take the 2 plus 3 and get 5 and cut it in half. You're just finding the average right there. So you add the two numbers up and divide by 2, and we get that the lower quartile would be 2.5. All right? So now for the upper quartile, we basically want the median of the upper half of the data. And so I'm just going to start to slash out. I'm going to get rid of the 6 and here. And that means the upper quartile is in the middle of these two numbers. So we just need to find their average. So you just add them up and divide by 2. So here, 7 plus 8 is 15, divided by 2. And we get the upper quartile would be a 7.5. So the 5 things you need are the lower extreme and the upper extreme. So that's just the smallest and the biggest number. You need the number in the middle, and then you need the lower quartile and the upper quartile, which are basically the median of the lower half and then the median of the upper half of the data. Now let me show you guys a different data set and talk you guys through what happens if when you slash there is no number in the middle to circle them. So if I crossed out the 1 and then the 8 and then the 2 and then the 7 and then the 3 and then the 6, I have these two numbers that would be left for the median. So once again, I just add them up and divide by 2, and that's the number in the middle. Now folks, when this happens, when you have to find the average of these numbers for the median, now when you are finding the lower quartile over here, the 4 goes with the lower half of the data and the 5 goes with the upper half. So now I'm going to slash through for the lower quartile, smaller to bigger, and then we still have these two left in the middle. So we find the average, lower quartile. And then on this side, the 5 slashes out with the 8. We have two numbers in the middle, so we average them up, and we get a 6.5 for the upper quartile. Now let me show you guys another data set. This is just random numbers that I wrote here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers in this data set. Once again, easy to identify the smallest number once it's ordered from least to greatest, and then it's going to be easy to find the upper extreme because it's the biggest number ordered from least to greatest. Now, when we're slashing through these numbers to try to find the number in the middle, I'm going to do this one in red. I've slashed out the lower and the bigger, and then I'm just working my way inward, okay? And this is what you can do on your paper. You can just slash them out and work your way inward. Now you'll notice here, we have to add these up and divide by 2, so the number in the middle here is 11. Now, once you split the data, the 10 goes with the lower half, and the 12 goes with the upper half. So now I have over here this data set, and then I have over here this data set. And if the data set is large enough, like this one, now when you're trying to find the quartiles, you'll have a number in the middle. So I'm going to reset now with all the slashing. And so now I'm going to slash out the 3 and the 10, the 7 and the 9. And right there, I have a number in the middle for my lower quartile. And then same thing on this side. I'm going to slash out the 12 with the 19, the 15 with the 18. And then I have an upper quartile in the middle. So this slide was meant to review how to find the median and then the two quartiles. And sometimes when you split the data, there is a number all by itself in the middle. Other times you need to find the average. Okay? Now let's go back to our example and let's find the 5 numbers that we need to be able to draw the box and whisker plot. And then I'm going to show you guys how to draw the box and whisker plot. So, what is the lower extreme, the shortest distance that anybody traveled to get to this restaurant? Just 1 mile. What is the upper extreme, the longest distance, the biggest number? So we have that somebody has traveled 30 miles to get to this restaurant. Now, the number in the middle here, as you guys start to slash and slash and slash, just think of it this way. If you have 20 pieces of data, half of that's 10. So notice that I've drawn my purple line right here, and I've got 10 numbers over here and 10 numbers over here. So the number in the middle, we actually have to average up 4 plus 6 and divide by 2. So 4 plus 6 is 10, and then when we divide that by 2, the number that we get in the middle there would be a 5. Okay, so 5 is technically the median. What that means, y'all, is that half of the people who responded drove less than 5 miles to get to the restaurant. That also means that half the people who responded drove more than 5 miles to get to the restaurant, okay? Now with the lower quartile. So if I erase, I'm going to show you guys, oops, let me just get rid of the purple here. There we go. All right, so what we're going to do now is review how to find this quartile, and we had the data split already, so now I'm just going to slash the 1 and the 10, the 2 and the 9, the 3 and the 8, all the way till I find my way to the center. But right here I can see I've got 2 numbers in the center, so we're going to add them up. 2 plus 3 is 5, cut that in half, and we got that the lower quartile would be a 2.5. All right, now same thing over here. When we get to the center, it's going to be the 11 plus 14, which is 25, and then cut that in half, and we get that the upper quartile is going to be a 12.5. All right, so now we have the 5 numbers that we need to create the box and whisker plot. Down below on this number line, we have it going from 0 to 30, and the first thing we're going to do is start with the lower and upper extreme, and we're just going to plot points. So the lower extreme was 1, so we're going to put a point right here. And the biggest was 30, so we're going to put a point right here. Now the median is 5. So right there, I'm going to draw a vertical line. And the lower quartile was 2.5, so that's going to be halfway between the 2 and the 3. And the upper quartile was 12.5, so it's going to be right there. And now I'm just going to draw a box to connect, and I'm going to use the straight line tool here to connect here to make the whiskers. And we have just drawn a box and whisker plot. Now let me kind of talk to you guys about what you're looking at here. Okay, when we found the median, we cut the data in half, then we cut it in half again and in half again. So what we've essentially done up here, y'all, is we've put the data into 1, 2, 3, 4 different sections. Each of these sections are called quartiles. All right? We broke the data up into 4 different sections, and they're quartiles. Now down here on the box and whisker plot, what we're saying then is that 25% of the data is in this section, 25% of the data is in this section, 25% of the data is in this section, and 25% of the data is in this section. Here's a big misconception with box and whisker plots, okay? This is a really important part of the video. A lot of people think that because this part of the box and whisker plot is the longest part, that represents the most of the data. That is not true, y'all. From 12.5 to 30, up here in the data, from 12.5 to 30, we can see that that's 1, 2, 3, 4, 5 pieces of data. 5 out of the 20 reduces to 1/4, which is 25% of the data. 25% is in that section. Even though it's longer, it doesn't mean that there's more people represented in that data set. Now, also, I want to point out over here in blue that this short little whisker, that makes people think that there's not a lot of people in that category, and that's not true. All it's saying is that up here, from 2.5 down to 1, which is all of these, we'd have 5 people who said that they've traveled that distance to get to the restaurant. So once again, we have another 5 out of the 20, which is another 25% of the data right there. So if 25% of the data is right here and it's these 5 people, and 25% of the data is right here and it's these 5 people, that means that the rest of the data is contained within this box, and that should represent the other 50% of the people who responded. And right here, we can count up those 10 other people, and that would be 50% itself. So don't go thinking that because this box and whisker plot has a long section over here that there's more data here. No, that just means that there's a really big spread of the data on this part, while over here the data is really consistent. Notice that the values 1 and 2 are all right next to each other, but for the yellow part it has to spread from 14 all the way up to 30, so there's just a bigger range in with the length of that part of the graph. All right. So down here are a few key features of the box and whisker plot. The entire graph is 100% of the data. All of the results are shown in the box and whisker plot. Now the median represents the center of the data, so all we're saying then is that half the data, 25% and 25%, is below it to the left, and that this 25% and this 25% is to the right, and that's also 50%. Each of these quartiles, the 4 sections, represents 1/4 of the data, or 25%. And what this does is it allows you to analyze the spread of the data. Is it closely clustered or really spread out? For example, this red box and whisker plot shows data that's really consistent and close to each other, while this shows data that's going to be really, really spread out and have a big range. Okay? Now what you're going to do next is you're actually going to move on to this part for practice, and we'll go through that together. But that concludes the video for how to construct the box and whisker plot and then how to analyze it. Thank you.